Hey all. So I remember how excited I was to start running Rust code coming from Solidity, and I was like, why would anybody want to keep their Solidity code and when they can just learn Rust and do it that way? Well, I was young and naive. A year or two later, I built and I launched a product, and after months of just ridiculous hours, I was like, why would anyone want to rewrite their code base when it's already kind of working? Like, oh yeah, you have a scaling solution, fantastic. Can I just copy paste my code over and maybe sleep for the first time in 3 days would be nice. So the point being that opening up a platform to a lot of different kinds of languages is a very good choice. And doing so through WebAssembly might be also a very interesting design choice too, a good one. So, not about me talking about that. Let's introduce Michael Yuan of ParaState and let him take over from me. Michael?
All right, thank you. So I can start, right? Okay.
Yeah, you're good to go.
All right, yeah, thank you. So my name is Michael Yuan, and I come from ParaState. So I want to talk to you about the next generation of Ethereum as Substrate. So the next generation of Ethereum is not going to be on Ethereum, it's going to be on Substrate, and I'm going to tell you why. So if you're interested, you can, you can email me at michaelyuan.com. That's, I think you can find my email address in the program. So, and by the way, this project is funded by a generous grant from the Web3 Foundation. So, that's the work would not be possible without Polkadot and the Web3 Foundation. So, I'm aware this is a Polkadot conference, but I'm going to still have this slides come up here to say Ethereum, the protocol is winning. Especially. It's not to say it's Ethereum as a blockchain protocol, consensus protocol itself is winning. It's Ethereum as an application protocol is winning. Why? Because we can see that these days when you launch a new public blockchain or even a parachain or even even a blockchain in one of the ecosystems, one of the first things you're going to do is you're going to say I'm Ethereum compatible. Because there are lots of applications and a lot of financial assets, a lot of crypto assets that's already written in the Ethereum, written for the Ethereum protocol. It's very difficult to move them to an entirely new ecosystem. So because of the network effect, it's already there. So so you see all those new projects. That's started with their own idea of how to write applications, but in the end. But they're all moving toward one direction. That they were all trying to support Ethereum on their blockchain, right? However, this being a substrate conference, what I want to argue is that although the Ethereum protocol has become more and more popular and have a strong network effect, the actual implementation of Ethereum, the Ethereum virtual machine, the EVM, is not winning. That is another way to say that although there's a lot of applications building on that protocol, but the winner of the blocking ecosystem may not be the Ethereum mainnet. It may be something else. In this particular case, we want to argue that it's maybe Polkadot, right? So there's a couple of reasons why the Ethereum, the implementation, the Ethereum, the protocol is winning, but the Ethereum, the implementation, the EVM is not winning. The first, of course, is the EVM is slow. We all know that. We all know that the Ethereum mainnet is slow, but a lot of people also know that the EVM itself is slow because it started as largely an academic project. It's not an engineering project, right? So it's a virtual machine that runs in the interpreter mode, and it's far outside of the computer science mainstream. So as a result, it's difficult to optimize because it's non-standard. And it has some, what I would best say, outside of mainstream features like 160-bit integer, things of that nature, that is not found in any computer hardware or other VMs, right? So as a result, the Ethereum mainnet only processes like 8 to 10 smart contracts per second. That's you can compare this to JavaScript. Right, it's not very fast. It's running in the interpreted mode, and there's a long in terms of performance. It's a long way from say a native application or a compiled application. So this first thing, Ethereum is the EVM is slow, and the EVM is also unsafe. There are many cases of hacking around the EVM. And people may argue it's not necessary to say that the EVM itself has a bug, but it's certainly the case that the design of the system has some issues that people can explore, right? There's a very very famous DAO hack, in the early days of the Ethereum network, and this hacking has goes on until today, right? Even today, from time to time, you will see applications being hacked or applications being front run. There's lots of issues with the particular implementation of the EVM. Okay, so the third problem with the EVM is the EVM is not designed to be extensible. Meaning that's it's designed to be one block of code. You can just use that block of code as a virtual machine, or you cannot use it, right? It doesn't provide a way for you to extend it, to add custom features to it. So, for instance, this is a paper that we wrote with Oasis Labs, right? The idea here is to build a privacy-focused virtual machine so that we can have a privacy-minded smart contracts. And in order to do that, we need to make some modification to the Solidity language, for instance, and to be able to mark out which data fields are confidential and needs to be executed in what they call TEE, trusted computing environment. Yeah. Trusted computing enclave. So that's so there are lots of things that's people want to do in order to accommodate different applications. People want to extend the function of the EVM and extend the functionalities of languages running on the EVM, and they can't because the EVM is written in a way that is not extensible. The particular implementation of the EVM. And as large as the Ethereum developer communities are, it's a very small developer community compared with other programming languages, like even with Rust, compared with Rust, and let alone JavaScript and C++ and people like that. I remember and a year and a half ago in Osaka, in the last DevCon, there was the slogan of 1 million developers, right? We want to get 1 million Solidity developers on the Ethereum network, and I think we're still pretty far from that goal. I think it's the most recent figure is maybe 100,000. But even with 1 million, this is like a fraction of Java developers, for instance. There's like 40 million Java developers right there, right? So compared with other computing language communities, the Ethereum has a very small The EVM has a very small developer community. So with all those issues, how do we solve those issues? That's while still preserving the network and the nice things about the Ethereum protocol. So what comes to rescue is what they call EWASM, the Ethereum flavored WebAssembly. So meaning we stick to the Ethereum protocol, but we change the implementation of the EVM into a more modern architecture. This more modern architecture is called WebAssembly, because WebAssembly is a virtual machine standard originally developed for the web browser. And it's supported by all the big guys like Google, Microsoft, Apple, Mozilla. Every one of them support WebAssembly. So there's a very large standard organization and a very large developer community in that space. By bringing the WebAssembly virtual machine into the blockchain space, in particular, by re-implementing the EVM as a EWASM virtual machine, we can benefit a lot from the larger community that's around the WebAssembly. So the most important feature about EWASM, it's called EWASM, Ethereum flavored WebAssembly. It's Ethereum compatible, meaning that's the virtual machine understands and can process Ethereum transactions. It can understand the address format of Ethereum. And so because of that, it works with all the toolings that's built around the Ethereum ecosystem. For instance, the MetaMask wallet, for instance, all the dApp applications, right? Those DeFi applications. Those applications, because those applications all leverage the underlying Ethereum account system and the storage system, because EWASM understands those systems. So applications that written and the tools written for those applications and in that ecosystem would be able to work out of the box in the EWASM compatible virtual machine or EWASM compatible blockchain. So the second important feature of EWASM is that EWASM, because it's WebAssembly, now it supports multiple programming languages. It's not just the Solidity or FE or Viper, which is no longer being developed, right? So because WebAssembly connects to another large ecosystem of compiler geeks, it's called LLVM. So on the front end, it's for 20-something programming languages, for Rust, C++, Swift, Go, and a bunch of other programming languages. And then on the back end, you can use the LLVM compiler and generate code for the WebAssembly runtime. So in that case, EVM allows us to use many different programming languages, not just Solidity, and then use them to write Ethereum compatible smart contracts. And I think that's a very powerful feature that allows us to really grow the developer community. And because WebAssembly is a more modern architecture, so the VM has a modern architecture compared with the regular EVM. So it supports something called dynamic compilation. That's something you weren't heard in terms of how to make the VM run faster. People say use JIT or use AOT. Those are very important compilation techniques that allows the virtual machine to run much faster. On-chain and off-chain, right? So by published numbers, if you run a WebAssembly virtual machine and EVM on the standalone mode, that you would be able to see in AOT compiler mode, you would see the WebAssembly virtual machine can run 100 times faster than the regular EVM interpreted mode. So we're going to be able to see a much a very significant performance boost by using EWASM to replace EVM as well. And of course, one of the other features that we talked about is that the WebAssembly being a large ecosystem, it supports many extensions. So there's a mechanism to plug in new features into this VM and to make it do things that you want. To have custom language extensions that are specific to the use case of your blockchain, right? So if you have an application-specific blockchain and you need a particular language to be supported, like the Facebook Move blockchain, they have a Rust-like language that does financial transactions. It's essentially a domain-specific language, and if you want that to be supported, you can. There's a mechanism for you to modify the WebAssembly runtime and add those features into the VM. All right. So now we have talked about why do we need EWASM. In the next couple of minutes, I'll show you how to play with this on your own, and if you're blockchain developers, how to incorporate this into your own blockchain. So the first choice, because this is a fairly long document, I would go into the details of this document. You can find this link on the slide, which is a tutorial. If you want to start a standalone Substrate blockchain with EWASM, there's a tutorial on GitHub that you can follow that process to start your own blockchain, and that blockchain would have EWASM, and then you would be able to interact with a virtual machine as you would interact with any other Ethereum-based blockchain. I'm sorry. And then the second choice is if you already have a Substrate-based blockchain and you just want to add another VM into the blockchain, you already have your own consensus, you already have all the other elements. You may even have the EVM already, but you want another VM to process the EWASM transactions. So people can put the EWASM bytecode into their transaction and submit to your blockchain and have it executed, right? There's another So in that particular case, we have a pallet called Pallet SSVM, and you can in building your own blockchain, you can select this pallet and incorporate that into your own Substrate blockchain, and you would have EWASM functionalities and the VM in it. Or if you just want to play around, you can just use the ParaState blockchain, which is currently is our testnet that we set up to have both EVM and EWASM. So you can have all those Ethereum toolings and experiment with Ethereum smart contracts just as you would with any other Ethereum compatible blockchains out there, right? So you can run Ethereum smart contracts, you can run, connect wallets, connect IDs, connect developing tools, and do all those things. It's so this ParaState testnet is what we call Ethereum on steroids, right? So it is Ethereum, but it's faster. It's more languages, so it's faster and stronger, and built on Substrate. Try it out. So I have some videos, and I put the link in the slide deck. I won't have time to play those videos right now, but I think if you're interested, each of them are only a couple minutes long, like 4 or 5 minutes long. So you can go through and then get a feel of how the software works, right? So the first is compile and build a smart contract. Here is you can write your contract in Solidity, or you can write it in Rust. And then you can use LLVM compiler. And we have a Solidity compiler as developed as part of this project called SOL, right? It's Solidity on LLVM. So that allows you to compile the smart contract from a language of your choice into WebAssembly bytecode. And this WebAssembly bytecode can only run on EWASM. It will not be run on regular EVM. So you need a EWASM compatible blockchain. You can either create your own or use the ParaState testnet. And then once you have the bytecode, you can submit and execute to Web3. There's a tutorial for that. We have the Web3 gateway developed and set up with the rest of our software. So you will be able to use Web3 compatible infrastructure like MetaMask, right? And create a DApp, and then use JavaScript to submit the WebAssembly bytecode onto the blockchain and set up a smart contract, and then call the message to the Web3 interface. It's Web3.js, of course. Or you can use Polkadot.js, because Polkadot.js is a very nice tool that's set up for substrate-based blockchains, right? So each of you can generate your wallet address on it, and each of the Polkadot address can have a corresponding Ethereum address. So you would be able to switch between them. And so the video shows you how to find, get one address from another, and then use the Polkadot.js to deploy ERC20 smart contract on the EWASM blockchain, and then try to make a coin transactions from it. So I think that's that's my time, and I think I may have a couple minutes for the Q&A. But that's all my slides. Thank you very much, and I do hope you have the opportunity to go and check out our software to start your own Substrate blockchain with EWASM, or to just play with the testnet we already set up. And the software is still under active development. And if you are a blockchain developer, and we invite you to join us or to try out our software on your own Substrate blockchain as well. Thank you.
Amazing. Thank you so much. That was a fantastic presentation. Got a few questions in. One of them is, chains that already have their EVM, would there be like an easy way to integrate or use yours instead, or with their own EVM? Or how do you kind of see that working together?
Right. So the nice thing about EWASM is that it can exist side by side with the EVM, because the bytecode format is different. So when you submit a smart contract through the Web3 gateway or the RPC gateway, the gateway could detect, is this a EVM smart bytecode, or is this EWASM bytecode? And it would be able to route the transaction to different VMs accordingly. So that's a nice thing about EWASM. It's not it can replace the EVM, but it doesn't have to. It can coexist. It can exist side by side with the EVM.
Oh, that's amazing. One more question. We got time for one more. Just in your general journey building with Substrate, how did you find using it? Things you liked, maybe you didn't dislike, or things that you can impart to new Substrate developers hopping on?
Yeah, well, I obviously, we like the Substrate very much because this is one of the, it's a very much, I like the Rust language very much. And it definitely helped. The Substrate is written in Rust, right? That's. But the other thing is that we like the modular architecture. It's the way that's things are set up so that you can pick. So that people can pick and choose the components that they like. In building our own test nets, that we have experimented with a lot of the palettes that's built, both built by the official Polkadot project and also built by the community. I find them to be very interesting. There's lots of functionalities, and so it's a very vibrant ecosystem. So we definitely like it a lot. One of the, if I may, one of the features that we do have some issue with is in the Parachain setting, the whole substream mode is running inside WebAssembly. So that means the EWASM is actually WebAssembly running inside WebAssembly. Just think about that. That's so we have something that's running as a WebAssembly, and then we have another WebAssembly virtual machine that's running inside it. That has caused some problems for us, but we are working it out. But overall, that we find the architecture very elegant, and it's definitely if you are looking to start a new blockchain project, whether you want to join the Polkadot ecosystem or not, if you just want your own standalone blockchain like the Binance Smart Chain or something like that, that's I think it would be Substrate offers a great starting point. It offers many tools from the ecosystem that would make your development much faster. So overall we like it a lot.
No, awesome. That's a great answer, and definitely a really interesting challenge, which does sound really fun to hear about later too. So yeah, thank you so much for taking the time. We're about to go on a 20-minute break, so please enjoy the awesome vibes of the DJ music that's been coming through, very Berlin-y vibes, and I'll see you guys in about 20 minutes for the next talk.